So estimation is a skill that you were probably taught at primary school, and then it's sort of gone out of favour. It's really important for us to get a rule of thumb and an estimate of what's going on around us. So for example, I always get really annoyed when I'm in the supermarket and somebody's bought lots of things. Well, now this happens a lot less because we use cash less, but they used to get to the till and they'd be sitting there going, I've got all these things, damn, I haven't got enough money. And you're sitting there and looking at what they've got in their shopping trolley, and they've, let's say they had £20, and you're going, there's no way that that could come to less than £20. What were they doing? What were they thinking? So estimation is a really useful skill to have. But extra to that, we can use evidence to improve our estimates of things. And that's the point of collecting samples and collecting data, so that we can end up with effective estimates of what's happening at the population level. So a question I asked a couple of times for the last few years, my undergraduates as a survey, is estimate what proportion of people in the class have been to the US. Now, I get a lot of answers like, oh, I can't make that estimate without any evidence. Well, you can always estimate. It's always a feeling. You can always make an estimate. It can be a bad estimate. It could be wrong, a non-evidence based estimate, but you can always make an estimate. So, let's make the estimate. So some people will estimate too high, and I say 90%. And some people will estimate too low, let's say 2%. And some people estimate somewhere in the middle, and you'll get a bit of a skew this way and that way. You'll get all sorts of different answers. But the interesting thing about estimation and the way people estimate is we're pretty good at it. It's one of the skills that allowed us to evolve and survive. So what we have is this property called the wisdom of crowds. And surprisingly enough, when I look at the estimates from my class, and I actually ask the question as well of all the students, have you been to the US? So I can compare the estimate of the proportion of students who've been to the US to the actual proportion. And what I find out is they almost perfectly match. So I've done this for 2 years in a row where they were so close they were indistinguishable. Now this is that Who Wants to Be a Millionaire Ask the Audience phenomena. If you ask the audience to answer a question, the average of that crowd is going to be better than your friend. They're as likely to make a wrong estimate than you are. Now, the important part of the crowd is there shouldn't be an expert amongst them. If you have an expert, they tend to sway the crowd and talk to the rest of the crowd, and this can end up with biasing the estimate. So if they think they know the answer, profess their expertise, and then get it wrong, they will have pulled the crowd's estimate to a bad position. Now, if you want to know any more about this, then go Giger Answer. It's written a book called Gut Feelings about this, and it's astounding just how successful it is. Now, what we want to think about is estimation in statistics. Now, you've already looked at estimates, and these are very specific types. They're called point estimates. So you use the sample mean and the sample standard deviation to make estimates about the population mean and the population variance and standard deviation. So the sample variance, when we introduced it, has an n-1 term, not an n term in it, which is the way you formulate the population variance and standard deviation. Now, the reason to do that is you make the estimate slightly larger than the one you found in the experiment. So this makes your estimate unbiased. So bias is when you systematically under or overestimate a quantity. So remember, in the diagram, what you're looking at is B. So that's a systematic underestimation of things. So by changing that n-1 term, we move all of the scatter in towards the bullseye. So we improve our accuracy, and we're more likely to get a representative estimate of the population standard deviation and variance.